Hey guys, Mr. Milton here. Today we're going to look at scientific notations notes. At the end of this video, you should be able to write a number in scientific notation, order numbers written in scientific notation, and multiply numbers in scientific notation. Okay, you should be accustomed to scientific notation a little bit, if not for your science this year, but science in the past. It is a way of writing numbers that are either very large or very small. And our rule for scientific notation, it's a times 10 to the n, where a, that number that's being times, is greater than or equal to 1 and less than 10. Okay. Notice it says less than, not less than or equal to. It cannot be 10. So a has to be a one-digit number. So which of the following numbers is written in scientific notation? As we look, first option is not in scientific notation because this is 52. It's greater than 10. Doesn't work out. B, we have 3.46. There we go. It's greater than or equal to 1 and less than 10. Times 10 to the negative 6, so that works out. B is written in scientific notation. C, it's not in scientific notation. We see that there's a 0.04. This is not greater than 1 or equal to. Okay, and then D looks pretty good. But notice that D has addition here. And so the addition would tell us that it cannot be, that's not scientific notation. Scientific notation includes multiplication. All right, so our first example says write a number in scientific notation, and we're given this number, which is hundreds, thousands, millions, billions. Okay, so $5.7 billion. How will we write that in scientific notation? And what we do is since our rule tells us that a has to be greater than or equal to 1 and less than 10, we will move this decimal point over until it's in a place that makes the a greater than or equal to 1 and less than 10. So it's 1 space, 2 space, 3 space, 4, 5 space, 6 space, 7 space, 8 space, 9 spaces. Okay, just put that 9 there so I don't forget. Okay, so at 5.7 times 10 to the, and then spaces that I have is my exponent, 10 to the 9, okay? Here's our thought process. As we go through, we should say, is this a big or small number? This is a big number, okay? Where's the decimal currently located? Okay, our decimal located at the end here. Okay, every number has a decimal. Even if we had just a number like 17 where we kind of ignore it, our decimal's here. It'd be like 17.0 if we made it a decimal, right? We typically don't write it that way, and so we don't think about this decimal, but it is there at the end. Where should it be located? Like I said, we want to locate that decimal where it's going to be greater than 1, greater than or equal to 1 and less than 10. And how many places is moved? This is my exponent. Okay, and then that goes full circle really back to that first question. Is this a big number or a small number? This is a big number in this case. If it's a big number, it means it's going to be a positive exponent. If it's a small number, it means it should be a negative exponent. Okay, notice that positive and negative exponents are going to be positive. Doesn't change whether our number is positive or negative. It changes whether our number is large or small. Okay, so as we go through this process, we can look at this and say, okay, this is a small number. Helps us out. Let me move my decimal here, more easily located. 1, 2, 3, 4, 5, 6, 7 spaces. Now I have my a as 3.1 times 10 to the 7. It's a small number, so it's negative 7. Okay, writing a number in standard notation or decimal form. Okay, and so we can go from standard notation to scientific notation, and we should be able to go from scientific notation to standard notation. Okay, and so here we have 5.21 times 10 to the 4. This tells me, this positive 4 tells me it's a big number. So it tells me I need to move to the right 4 times. Okay, and so what I'll do is I have this 5.21. I'll move the decimal point and count just like I did with going backwards. Is okay, I have 1 space, 2 space, 3 space 4. This is my decimal, and this is why I make the little loops or hoops, whatever you call it. In my empty spaces, I'll put zeros there. So 5.21 times 10 to the 4th gives me 52100. It's 52,100. Okay, you can put a comma there if you'd like to. I really don't like to though. 52,100. Okay. So we think exponent is a positive number. So this is a big number, a large number. I move the decimal to the right because it's positive. If it were negative, I'd move it to the left. If the exponent were negative, everything would be switched. It would be a small number and move the decimal to the left. I just said that out loud. All right, and so here's an example here that you have a chance to do. Okay, so that answer should be 0.009713. Okay, notice that when you're writing your answer, we do not round. Okay, so if the significant figures, or they gave us 4 numbers and given us our original number, when we move over, we don't say 0.0097, we'd say 0.009713. Okay, that's way too far. All right, now let's talk about ordering numbers in scientific notation. To order numbers in scientific notation, you must first make sure that all numbers are in really the same notation. Okay, but I'll say scientific notation. And I'd say scientific because if you had to make it in standard notation, if you got the number, let's say for instance, 6 times 10 to the 23rd power, to write that in standard notation, you'd have to write 23 zeros. Okay, you don't want to do that. Put it in scientific notation and everything in scientific notation so we can follow our rules. Okay, once it's in scientific notation, look at the exponents first. Okay, because that tells us whether it's a large number or a small number, and the bigger the exponent, the larger the number. Okay, and if they are the same, then the tiebreaker is the A value. Okay, so it says order these atomic particles from lightest to heaviest. Okay, and so as we look at what we're given, this might be what we get in a scientific or in like a textbook or something. It says neutrons are this number, electrons here, protons here. We should notice that protons aren't given in scientific notation, right? They gave us 16.749. That's not scientific notation. All right, so as we move this over, and rewrite it in scientific notation, we'd have 1.6749 times 10 to the, okay. So at the beginning of this, it says, tells us to move, the exponent tells us to move to the left 25 times. We moved once to the left to put it in scientific notation. And so we have 24 more times to move in order to put it in standard notation. So that's our new exponent here. So I'm making the A value smaller by 1 place, let's say that. Then I need to make the exponent larger by 1 to keep it balanced. Okay, that's how you want to think about it too. I always hear this as a nagging little voice. It says, move left 25 times, move left 25 times. And I move left once, and it would say, okay, move left 24 times, move left 24 times. Okay. If I do what it says, the number gets smaller. If I do the opposite, the number gets larger. Okay, or further away from 0. All right, so ordering it from lightest to heaviest. The lightest would have the lowest exponent, and that in this case will be our electron. Our electron has the lowest, so it would be the lightest. And then from there, our neutrons and our protons have the same exponent of negative 24. And so as we go through 1.674, 1.672, the neutron would be next, the next lightest, and the proton would be the heaviest particle. All right, and then finally, multiplying with scientific notation. So this is the first case, and we'll have more cases with other lessons. Okay, it says multiply 12 times 9.1 times 10 to the negative 7. Write your answer in scientific notation. Okay, very important to point out that this is not distributive property. Okay, with distributive property, you'd see this problem probably at 12 times 9.1 plus 10 to the negative 7, something like that. Okay, distributive property is when you're adding. Notice that all these are multiplication. I could easily, or just as easily, write this problem as 10 times 9.1 times 10 to the negative 7. Okay, and it's just multiple multiplication problems. Okay, with that said, it's going to be best for us to organize ourselves in a way so that we can deal with numbers in the way that we're familiar with. So I would recommend that we start and say, hey, let's do 12 times 9.1, since we've done problems like that a lot in our life. Okay, 12 times 9.1 gives us 109.2. So that's 109.2 times 10 to the negative 7. Now, the thing says write, or the instructions say write our answer in scientific notation. As of right now, we're not in scientific notation because A is not in greater than or equal to 1 and less than 10. So I want to move my decimal place over 2 spaces to make this 1.092 times 10 to the excuse me, times 10 to the, okay, so now we made this smaller by 2, so we need to make this larger by 2, negative 5th. Okay, or our exponent said move left 7 times, move left 7 times, and we moved left twice, and so we have 5 more to go. Okay, try your hand out on the next problem. Okay, so here's how it should have gone. You should have said, okay, 0.5 times 1.2 gives us 0.6 times 10 to the 8th. Good, did the multiplication. Now to make it into scientific notation, I need to make it so this is greater than 1. Told me to move to the right 8 times. I moved to the right 1 time, so it would say 7 more times. Okay. All right, that's scientific notation. Ordering them, writing from scientific notation to standard form and from standard form to scientific notation. See ya.